Hello everyone, this is my 8th video of the case study. I have taken up the topic of coordinate geometry in this video. So let us see what exactly is given to us. A tiling or tessellation of a flat surface is a covering of a plane using one or more geometric shapes called tiles, with no overlaps and no gaps. A periodic tiling has a repeating pattern. Regular tiling is done with regular polygonal tiles, all of the same shape, and semi-regular tiling with regular tiles of more than one shape and with every corner identically arranged. So you must have seen the tessellations in the floors also, in the wall tiles also. So various places you can see the tessellations. A real physical tessellation is a tiling made of materials such as cemented ceramic squares or hexagons. Such tiling may be decorative patterns or may have functions such as providing durable and water-resistant pavement, floor, or wall coverings. Historically, tessellations were used in ancient Rome and in Islamic art, such as in decorative geometrical tiling of the Alhambra Palace. One such example is shown to you. So this is the example that has been given to us. A craftsman thought of making a floor pattern after being inspired by the design below. To ensure accuracy in his work, he first made the pattern on the Cartesian plane. He used octagons, square, and triangles to make his floor tessellation pattern. So this is the pattern made by the craftsman. Using this figure, we'll be having some questions to be done in the form of case study. So the first part is find the area of the trapezium AFGH in square units. So let us see the figure once again. I want to find out the area of the trapezium AFGH. So A, F, G, and H. Let us find the coordinates of the vertices of this trapezium. A is what? A is -2 and 2. F is what? F is -2 and 9. G is -4 and 7. And H is what? It is -4 and 4. So the vertices, the coordinates are given here. Let me just mark up the area that I'm talking about. I'm talking about this trapezium AFGH. If I want to find out its area, I need to find out the sum of the two parallel sides and the height. Clearly, if you see, the sum of the two parallel sides is what? AF and GH are the two parallel sides. So A is how much? It is -2, 2, and this is -2, 9. So this is the distance between AF, A and F is what? It is going to be 9 minus 2, that is 7 units. Same way, if I want to find out the distance of GH, G is what? G is -4, 7, and H is -4, 4. So the length of GH will be equal to how much? It will be 7 minus 4, which is equal to 3 units. So I have GH is 3 units and I have AF is 7 units. I found out the length of the parallel sides. Now I want to find out the height of the trapezium. That is clearly 2 units. So the height is 2 units. I can find out the area by using the formula that the area of the trapezium is given by half into sum of the two parallel sides multiplied by the height, which is equal to half into 3 plus 7 into 2. That is equal to how much? Half of 10 into 2, which is equal to 5 into 2, which is equal to 10 square units. So this is the correct answer. I can safely say that C part is the correct answer. This is the first part done. Let us see the second part of the question. The coordinates of the centroid of triangle BKJ. Let us see the figure once again. I'm talking about BKJ, this small triangle I'm talking about. If I want to find out the centroid of this triangle, I should be knowing the coordinates of the vertices B, K, and G. B is clearly what? It is 1, 2. K is lying on the x-axis and it is at distance of 3 units from y-axis. So it's going to be 3, 0. The coordinates of J are 1 minus 1. So I have written the coordinates. I know the formula for the centroid. It is given by x1 plus x2 plus x3 upon 3, comma y1 plus y2 plus y3 upon 3. So I'll use that. I'll be getting the centroid as 1 plus 3 plus 1 upon 3 and 2 plus 0 minus 1 upon 3, which comes out to be 5 upon 3, comma 1 by 3. So what will I write? I'll write that this B option is the correct answer, right? So this is the second part done. Let us see the third part. What is the length of the line segment joining points B and F? Once again, let us see the figure. I want to find out the length of the line segment joining B and F. Coordinates of B are 1 and 1, 2. Coordinates of F are -2 and 9, right? So I'll find out the distance between them. What is the formula for the distance between 2 points? It is given by x2 minus x1 whole square plus y2 minus y1 whole square, and take out the square root of the complete thing. I'll be getting the distance. So the distance BF square is given by x2 minus x1, that is -2 minus 1 whole square, plus y2 minus y1, that is 9 minus 2 whole square. So it gives me how much? -3 square plus 7 square, that is 9 plus 49, which is equal to 58. So BF square is 58. Hence, BF will be equal to square root of 58 units. So which is the correct answer? Out of these, I can see that D option is the correct answer. Let us take up the fourth part now. The point on y-axis equidistant from A and G. Once again, we'll be needing the figure. A is given by -2, 2, and G is given by -4, 7. So the point which is going to be equidistant on y-axis. Y-axis, any point on y-axis is given by 0, y, right? So if I take the point to be as z, then AZ will be equal to GZ. Hence, AZ square will be equal to GZ square. So I'll be using the formula once again, the distance formula, that y2 minus y1 whole square plus x2 minus x1 whole square is equal to, again for gz also we'll find out the distance gz square. Let us do that. I'll be taking 0 minus -2, which is 0 plus 2 whole square, plus y minus 2 whole square is equal to 0 plus 4 whole square plus y minus 7 whole square. Let us find it out. This becomes 4. This is y minus 2 whole square is what? Y square plus 4 minus 4y. This is 4 square. Again y square plus 49 minus 14y is the square of y minus 7. I'll just make the cancellation. Y square and y square will cancel out. I'll be left with what? I'll be left with 8 minus 4y is equal to how much? It will be equal to 65 minus 14y, which gives me 10y is equal to 57, or y is equal to 5.7. But I was not asked why. I wanted to find out the point on the y-axis. The point on the y-axis was 0, y. So that will be how much? That will be equal to 0, 5.7. So 0, 5.7 is the B part. That means I can say that B option is the correct answer. Right? So I hope you are understanding. Let us come to the last part of the case study. The center of the figure will be the point of intersection of the diagonals of the quadrilateral WXOP. Then the coordinates of the center are, let us try to see the figure once again. They are asking for the point of intersection of the diagonals WXOP. So what are the coordinates of WXOP? W is -6, 2. X is a point on the x-axis, so it's going to be -4, 0. O is what? O is 5, 9, and P is 3, 11. They're talking about WXOP. Clearly, WXOP is a rectangle. So what will be the point of intersection of the diagonals? The point of intersection of the diagonal will be the midpoint of any of the diagonal, maybe of WO or of PX. So if I take the midpoint of the diagonal WO, so midpoint of the diagonal is given by -6 plus 5 upon 2, 2 plus 9 upon 2, which is equal to -1 upon 2, 11 upon 2. So which is that option? Clearly, C option is the correct answer. So this finishes off with the case study. Quite a few concepts of coordinate geometry have been taken up in this case study. Please go through the video thoroughly to understand the concepts better. Thank you so much.